a demonstration of RAC standby. That is, RAC is primary and the standby is a single node database. So first I'll show you, this is the first instance of the RAC database, SRV1 RACDB1. This is SRV2 RACDB2, and this is a standby alert log. So if the standby was lagging behind the primary, it would have started receiving and applying the archive logs after recovery. Like for example, here I started up the standby after a lot of archive logs were generated at the primary. So you can see after I started up recovery at the standby, it said, okay, it has received so many archive logs from thread 1, thread 2, thread 1, thread 2, and so on. That is server 1 and server 2, and it has applied them. So now it is in continuous recovery mode. So I'll just show you some of the queries that can be used. So this query shows that on instance 1, that is thread 1, 85 is the current log sequence being written to. Here 91 is the current log sequence being returned to. So you can see here from your 84 has already been applied, right, and 90 has also been applied. So 91 is the current being written to and 85 is the current being written to. That means it is standby is in sync. It is receiving the redo from the two primary instances. This query can show you that the difference has gone down only immediately after you do a archive log switch. Okay, because it compares the applied SCN from the standby to the current SCN at the primary. So if I do an archive log switch and it gets applied at the standby, then this time difference would shrink immediately. And there's another query. Gap status says, okay, there was a resolvable gap, so it is going to get resolved. Let's see. Okay, so here you can see, okay, after this 90, you can see 91 has also come through, and you can see now it has applied, it has opened the online redo logs and it has archived all the logs it has received in the past. So it is in the process of catching up with the primaries. Okay, so now it is applying the log sequence 95 from thread 2, 96 from thread 2, 90 from thread 1, because there is activity going on in the two primary instances. So now if I were to run this gap, okay, so the gap has got resolved. There is no gap between the primary and the standby. So these are the three queries at the primary. Thread 1 is writing 91. I'll just show you the query again. So I'm querying VDOLA manage standby. Here it is only LGBR, no MRP. And thread 2 is writing sequence 97. This is thread independent because it's querying from the database rather than the thread or the archive log. So you can run this query from any of the instances. So now the gap has come down. You could see earlier it was showing a gap of 11 minutes because the standby was catching up. Now it's down to 1 minute 21 seconds. So similarly, there's a few scripts you can query at the standby as well. So this query shows that from thread number 1 it has applied all the way up to sequence 91, and from thread number 2 it has applied all the way to sequence 97, which matches here, sequence 91, sequence 97. Then another query. So this is a query on the archive log status at the standby. So this was the DG applied query. Now I'll look at the DG apply lag query. So there's a query on VDOLA DataGuard stats which show you the transport lag and the apply lag. So you can see the lag is 17 seconds only now. Then you can look for the, okay, I'll just show the DG processes, the same query as we saw in the primary, but now you can see DG processes has two RFS, one for thread 1 and one for thread 2, and you can see now it is idle because there is no new archive log to be received yet, and managed recovery process is now waiting on sequence 92 from the primary thread 1, because 91 is still being written to. And then there's one interesting query which is on $v DataGuard status at the standby. So you can look at all recent messages. So at one point it was saying, okay, I didn't have a standby read log. Now it's saying, okay, I have opened the redo log, standby read log, and I have applied 92 from thread 1 and 98 from thread 2. So let's see what the current one is. Okay, so thread 1 is advanced to 93. So I should see, yep, so you can see now thread 1 92, and so thread 192 has already been applied. So this is the message number, this is the sequence number. Thread 192 has already been applied, and 93 is the current one from thread 1, and here 99 is the current, has gone from 97 to 99 because I have activity going on in both instances of my primary. So you can see it is now waiting for 99 at the standby. So this is how you can monitor the standby. I'll just show you the queries again. So for each thread, if your primary is a RAC database, you'll have multiple threads. So each thread you can see the messages here, and you can see currently for thread 299 is the one which is being applied. So that is what we were saying just now here, waiting for 99. So here it says 99 has not been completely applied yet. So this is the transport lag. You can see it has gone up a bit to 46 seconds. This query again is only at the standby, it is not at the primary. These are all the messages, recent messages. I'm just showing you the last 6 or so messages, and you can see thread 193, thread 299, and now thread 194. So it is already more advanced to thread 194. Earlier it was at 99 of thread 2 and 93 of thread 1 had been applied. Now it is already advanced to 93 has been applied, and 94 is what is waiting for. So it keeps switching between the two threads of the primary instance. So it will keep telling you in this view. I could change this filter from to show multiple messages. You can see the timestamps also for all the messages, and what was the archive log, which log has been applied, and which log it is waiting for. And the last query is the processes query. So you can see here from thread 201 and thread 195. Remember, in RAC, not all threads or not all instances will be at the same sequence number. One instance may be ahead of the other, so that's not a problem. You can have each instance have its own sequences. So now let's see what happens if I were to shut down one instance. Okay, so I've shut down. Oh yeah, I've set up something about the service, and I can't relocate the service, so I can't do it from SRVCTL. So I'll just do a quick shutdown from here. This was I was playing around with some service management. I'll just show a shutdown from here. And let's see if we can see anything in the messages. Oops. Okay, so there won't be any new message that is here. So it won't show any messages here right now, but I have shut down this instance. And if I just do so now this has gone to 97, thread 1 is gone to 97, so I should see thread 1 96 has already been applied and it's waiting on 97. Okay, so here it's waiting on 97. So the standby can continue running, receiving redo from one thread even when the other thread, the other instance of your primary cluster is down. So if you have a standby which is for multiple instances of a RAC cluster, you have to query by each thread separately at the standby status, or even when you look at the messages, if you look at the last few messages, you can see that there are informational messages and warning message. Now here you can see there was a warning message there. It got a disconnect from the primary, that is this was instance 2 which I just shut down recently. Okay, so there was a network disconnect. So this is, it's a good idea to periodically check your $V DataGuard status view at the standby. So your standby normally would not be open for read write access or read access by anybody. It will be in a mount mode, so you have to do a local connection SSDBA only to query this. You can't use a non-sysdba or a non-sysdg user to query the standby. So these were some of the queries. I'll see if I can post the queries in the comments in my YouTube channel. Thank you.